Hello everyone, it's June 23rd. Alright, we see it's a hard one today. Oh, let's see what it's gonna be. Okay, so there are n different online courses, number 1 to n. You're given an array courses where courses I is the duration and the last day. So it's the duration and the last day, indicating the ith course should be taken continuously for duration I and must be finished before or on last day. It will start on the first day and you cannot take 2 or more courses simultaneously until the maximum number of courses you can take. Okay. Now we have done this before, so let's see if we can summon some of the memory back. Alright, so what we have, so the first one is duration. So we have a duration of 100, the first one, and we must take in that at 200, number 200th day. And then the next one is 1300. And then the 200th day. 1250, 1000 day. And 3200, 2000 days. Alright, so the question is, how can we fit as many as we can? So 4 courses, which you can take 3 courses at most. Take the first course, it costs 100 days, should finish on the 100th day, and then ready to take the next course on 101. Second, take the third course. Gotta take 1000 days to finish on the 1100 day. The third, take the second course, it costs you 200, so you'll finish on 1300 day. The fourth course cannot be taken now since you finished on the 3300 day, which exceeds the close date. Ooh. Okay. What do you think? The maximum number of courses you can take. What I can say is, if I take a certain course, no clue at the moment. Take the first, then we go 100, right? And then if we take the second, then we go 300. And then I can take this, then we go 2300. But we cannot take this. So basically, what we're trying to do is add them up, right? We want to add these values up in a certain order such that as we add them up, the sum is always smaller or equal to the value behind us. In a certain order. Now we don't know what order that is. Of course, we don't want to take the big course first, because if we take the big classes, for like we say, if we take this one, then we'll have no chance to take the other one. So maybe we shall sort based on the final date. Okay, let's say we sort based on the finishing date, right? Okay. Well, maybe we should sort based on the duration that it takes. So when we start taking a class, right, there will always be a state, current state. Okay? Always say we have a current state when we start to take a class. The current state is the current day, right? Current day. So based on that, based on the current day, and then given a current, but we also have what has been taken. If I take this, then this become, if we start with 100, what's the maximum day, maximum we can take, right? If I don't take this, we can say if I start with 200, what's the most we can take? Well, we definitely have to take the small class first. If we have a class that requires the day is longer, is bigger than the end date, then these definitely cannot be taken first, because if you do that, then none of these classes can be taken. have no clue. Hints. Say I want to add a current course. Currently been total time of all the courses taken till now, but the current course might exceed my deadline or it doesn't. If it doesn't, then I have added one new course, increment total. Yeah, if like it is. But do we follow a sequence? I have the current time, and then they say if I take it. Yeah, the question is if I take. Oh, is this a knapsack? We want to fit these these courses in the time. It feels like knapsack. Well, to solve knapsack is whether you take it or don't take it, right? So here we can think about the same. So we have the current time coming in for each one, and then the question is whether I take it or I don't take it. But order means something here. Yeah, I think I'm troubled by the fact that order means something. How do we handle that? I would just go through all the scenario. Like we take the first one, right? And then we try to see based on this, and we have the remaining. What's the maximum we can get? And then we say we take the second one first. And then what's the maximum we can get for the remaining? So we need to have a set of classes that are not taken yet. And then we go through them one by one. How do you handle order? Hint number 2. If exceeds the deadline, I can swap current course with the current course that has biggest duration. So if it exceeds my deadline, I can swap with current course that has biggest duration. Biggest duration. This means the second one is the longest. No, wait, the first one is the longest. What? If it exceeds deadline. Has the biggest duration. Why would you want to swap the class with the biggest duration? I might just reduce the current total time. How? I don't understand. What do you mean? By swapping with the course with the biggest duration. Or you mean the biggest last day? No, I don't mean the biggest last day. It does mean with the biggest duration. Yeah, this is something I don't understand. If the current course already caused it to exceed the deadline, you mean we find something that does not exceed the deadline? Like, what the hell is that? I don't know. Look at the solution. What the hell? I time. What's the idea here? Yes, we take both classes. So I have different cases. Oh, oh. So this is both classes can be taken. One is we cannot take both. A is larger than B, and both can be taken by Y. Now in that case, if we take B first, A plus B is larger than X. So if we take B first and take A, then we cannot take A anymore. But if we take A first, then take B, then we can take both classes. So take the smaller first is more viable. What is this situation? The situation is B larger than A. That's the same. It's just A before B. So A plus B is larger than X. So I cannot take B and then A. And B is larger than A. But we can take A and then take B. It's now true. B is larger than A. A plus B is larger than Y. Yeah, we cannot take, so we can either take A or take B. Is that all the cases? A plus B larger than X. A plus B smaller than X. Yes, A plus B smaller than the first scenario. A plus B larger than Y is the last scenario. So the other scenario is just A plus B is between X and Y. And with A plus B between X and Y, and we say X is smaller than Y, so A is going to be smaller than B, right? Because our prerequisite is A smaller than X and B smaller than Y. And A must be smaller than B. So in the third situation, I don't see how you get these. These two is the same thing. A is smaller than B. And this is A larger than B. Oh, it's possible. A can be larger than B. Yeah, so in that case, either A smaller than B or A larger than B, okay? So if A is smaller than B and A plus B is smaller than Y, so if we take A and then take B, then we can take both. Yes, but if we take B, then take A, then plus A plus B is larger than X, so we cannot take A. So in the second scenario, say A is larger than B. So if A is larger than B, if we take A and B, that works. But if we take B and then take A, then it doesn't work. So we always have to take A and then take B, right? So in all these situations, it's always take A and take B. That will give us the best. Take A and take B. So no matter what. Which means, so like we have a course, let's say A and X and B and Y. And then X is smaller than Y. And then of course A is smaller than X and B is smaller than Y. If A plus B is smaller than X, it doesn't matter which one we take. If A plus B is larger than, well, it also doesn't matter because we can only fit one, right? And if A plus B is smaller than Y but larger than X, then we should take A first and then take B, no matter what. So in that case, we should always take the class with a smaller duration. No, that's not duration, that's the end date. We should take the class with a smaller end date first. Okay? So we do sort it based on the end date. And then we try to go through with, so the smallest should always be taken first. So we just keep taking until if we cannot take that anymore, then what? Well, they basically just saying we take some and then we just what take the next one. No, still no idea. But now we have an order. With this, we have an order. If we have an order, then maybe we can use DP for this. So now we say we have an order, right? We have the class lining up, and then we can say we start from the first one, right? And then we say I either take it or I don't take it, right? So if I take it, then I have the thing, whatever I have, and then go on to the second one. And I have an I have an index, right? I have an index. And or if I don't take it, and I also have an index. So basically we try to find out which one allowed me to take the most number of classes. So in that case, we can try so what we're saying is we're going to sort when you sort based on the second one, right? And then def helper, we're going to have the current time index, right? That's what I think. And then we're going to return an int. Then we're going to say from tools import cache. Okay, so with this we say add area cache max size equals none, right? Index, say n equals len course, right? And say if index is equal to n, that's return 0. I've taken 0 classes, right? And then we have a starting time, have index, right? Now we just decide whether we can take it or not. So we say we can choose to take it, right? We just say if current time plus courses index 0 is larger than courses index 1. I can say if index equal to n, or, so in both cases we say we're going to return 0, because this just means the current class I cannot take. How many classes I can take? I cannot take. Otherwise, I choose to take or I don't take. If I take, right, if I take my class, that's a 1 plus current time, 1 plus helper, so it'll be current time plus courses index 0, index plus 1, or if I don't take it, which is just current time and index plus 1. So when you return the maximum between the two. And then what we're going to return is helper, current time is 0 and the index is 0. Right, let's throw some test cases at it and see if this understanding is correct. So we have this shall return 3, this shall return 1, zero. Huh. Interesting. All right. So what we have here is courses. This shall be scheduled courses. Oh, we pass. There's a timeout. Okay. So, oh, I thought timeout. Didn't time out a wrong answer. Huh. Expected 1. What? 100. All right, so we have to filter this out. Sorted. C for C in courses if C0 is smaller or equal to C1. Hold on. Then sort. Then change this SC, let's call it SC. Okay. Try it again. Yeah, something's not right. Wrong answer. What did I do wrong? So I would take this 6, 8. I can skip. I don't have skip. Yeah. Why do I do this way? I don't know. If this, definitely. And then say if this, then we just skip it, right? We just return helper. I say current time. We just say cannot do this one, right? And then there's current time index plus 1. Yeah. I don't understand. What's the fuss? If I cannot do it, I just don't do it. Try it again. Memory exceeded. Okay. So this is correct, but memory exceeded. Okay, let's try our own memorization then. Oh, but current time and the index. We can turn this into a manual. So I'm not sure if manual will actually work. We'll make it a dictionary. I don't know. Say current time in dp and index in dp current time. Return dp current time and index. And then dp current time n equals 0. Okay, say elif dp current time index shall equal to this, else to maximum and then return index. Not so that's basically a default dict of a dict. She's saying this one will work. We roll our own. I always think the other one will be faster, but I've been proven wrong many a time. And all the repeats, right? I'm going to say tuple C and then equal to a set. Set has no sort. All right, sorted this key equals this. How about this? And kind of just get rid of any of the duplicates. We don't like duplicates. Alright, let's see. Is it memory exceed? Yeah, we're still exceeding. How do you solve this one? No clue. Huh? keep. All right, think about it. So this solution works, but it just takes too much memory, right? So we cannot do it. So what is the idea? Oh, it's not replacing the class that have not taken. It is as we go through, we will have taken some class with durations, right? Certain durations. And then once we hit someone that we cannot take anymore, right? And so far we've been taking classes with the shortest last day, right? So we're taking class with the shortest last day, and then I cannot take another one. The reason I cannot take another one because in the previous one I've taken something that the duration is too large, right? It has too large a duration, so I need to reduce the duration. Well, why does this always work? So we have to take the class with a shorter end date first, right? That's definitely. But when it doesn't work, when the shorter end date doesn't work, it basically means something is too big. So we pop this out, and then we just keep going. But why does this one work? Yeah, this one does work. Yeah, this is too. So it is greedy. Mm-hmm. Yes. Yeah, I have the solution. So as we go through, and then we find that like we cannot keep taking is because some class has too big a duration, right? So that's why it's exceeding. So the ideal is we need to swap this class out because this is giving us a trouble. So we take this out and then we swap the new class in. So we want to swap out the largest that we have and then put a new one in, right? Now what if it's still exceeding? Then we say, okay, if it's still exceeding, then we pop this one out. We keep looking, right? We keep looking because every time we look, we are extending the end date. So every time we add a class, we're become a little more lenient, and because we become a little more lenient, every time it goes in, the time also increases just a little bit, right? Just a little bit. I think it's here. Uh-huh. If we aren't able to take, we can try to take this course by removing some other courses. Only if the duration of the course being removed is larger than the current course's duration. That's true, because with a current course, we're exceeding, right? So if we remove it and I put something smaller, which just means we take that class earlier, and because that duration is smaller, and then it's definitely gonna work. So we just swap this in. Okay. But if it's larger, then we cannot do. So we have to swap it in. Mm-hmm. Yes. So what we're saying is we keep it pushing to the queue, right? And then once we cannot do, we pop the largest out, and then try to see if I can do the swap. So you're saying we have to go through every single thing, right? Try to see if there's any swap possible. If there's no swap possible, then what do we do? it says if such a course is found, we have to find one by one, or remove this course from the taken courses and consider the current course is taken. So mark this course with -1 to indicate this course has not been taken and should not be considered in the future again for replacement. But if such a course isn't found, we can take the current course at any cost. That's why we mark the current course with -1 to indicate that the current course has not been taken. And then we just keep going. Right? So basically, we have the total right now, and then we try to current course. If it can taken, push into the queue. If it cannot taken, largest one pop out. Right? Largest one pop out. And then we try to see in the remaining which one is smaller. Which one is smaller? If we find something that's smaller, then we put that one in, and then we indicate that one has been taken. And then we just skip the ones in the middle. Yeah, I think that's what it means. Oh, if this current one cannot taken. Oh, current one cannot taken. Why you pop this? I should say pop the largest one. Try to see if there's anything smaller. So current largest. So we cannot swap this in. Yeah, so we'll push out the largest, and then we need to start look for something smaller. This we cannot do. So this we can do. Huh. Wait, what? 3 plus 5 is 8, so I need to pop this one out. J, duration J is smaller than duration I. Why don't you keep looking? It should be nothing then. Yeah, I think you have to keep looking the entire thing. Only if it is larger than the current duration. Because if the max duration is larger than the current duration, we can guarantee that the swap results in a larger gap. You don't have to check for it separately. What if it's so, which means if it's smaller, then we don't do it. Hold on. So what it means is we pop the largest, and once we pop the largest duration, we compare that with the current. If the current is smaller, right? If the current is smaller, then we do the swap because we know the swap will definitely work. But if the current is bigger, we don't keep going on. We don't keep going on. We just say the current, we don't take that. We don't take the current because the current will not make it work. Again, remember, the whole point is to pick the class with the smaller end date as much as possible. All right, so we do one by one. We'll try to see if I can take the current class. If I cannot take the current class, then we try to take the next class because that has the smaller end date. If I can take the current class, I take the current class, just swap it out. Okay, so again, we're gonna sort like that. Remove the things that's giving us trouble. And then we're gonna say so. I'm gonna take the first one, sure. We want a max heap. So it's going to be I only need the minus SC0, 0, that's it, that's all I need. Now we say for I in range 1 to n, right? We say if, and I say current time SC01. Now it's 0, 0, 0. Right? We say if current time plus SCI 0 duration is smaller or equal to SCI 1, so we can take it, then heap q dot heap push heap minus this, right? Else else Now previous to max shall equal to heap q dot heap pop. Pop heap, put a negative sign on it. Right, so this is previous max. Then we say if pre-max is larger than current time, not actually current time. It's actually current time plus equal to ci0. Right. So if it's larger than sci0, right? If it's larger than, then we do the swap. Right, then we say heap q dot heap push heap minus ci0, and then current time equal to current time minus previous max plus ci0. Right. That's if we can do the swap. But if we cannot do the swap, like, then we just ignore the current one. Right, if else, then it's the same. Then we just heap q dot heap push heap pre-max, push it in, and then at the end of the day we return len heap. Heap pop. Index out of range. Oh. If not sc, return 0. Okay. So why is it not a nightmare? This is typical nightmare problem, look like this. I wasn't able to solve it. So there are two pieces of very important insights. One, courses with shorter but smaller end date must be taken for those with larger end date because of exhaustive analysis on different situations of two courses. The solution gives a very good demonstration of that. Second, once we sort, right, courses based on the end date, we must take classes in that order as much as we can. So whenever we encounter a situation, right, a situation where the current time exceeds the current end date, that means we must have That means we either have taken a class before with too much duration, or the current class has too much duration. To identify which scenario it is, we use priority queue to record the duration of all taken classes. We pop out the largest one and compare it to the current class. If the current class has less duration, swapping it in is guarantees that we swapping guarantees legality, guarantees to be legal because the total time actually decreases in this case. So swapping is definitely legal, and we reduce the total time, which means we're able to take on more classes. If the current class has more duration, then we skip it. So following this greedy approach, we have the following implementation. Let's see. Oh, and log in. Very tough. I think I use a different solution for this one. So we sort, heap. Smaller equal to, we always add. Push, add, no problem. Else, wow, heap 0. If it's smaller, I push it back so I can avoid a push. If I don't do this, right? I simply say elif is going to be heap 0. If this is larger then heap q dot heap pop heap, and I push this, and then pop this. And this, we just don't have to push it again, like that. Yeah, now this becomes the same. Alright, that will be it. Pretty bad, but it's okay. From time to time, this type of things happen. I'll see you guys tomorrow. Adios.